am 1 kilometre into this giant tunnel that lies 100 metres underneath the ground. This is one of the largest engineering projects in Britain. In this episode, I'm going to be looking at Wales's most extraordinary engineering.
My name is Millard, and I'm a writer and adventurer. Although I've explored some of the world's most inaccessible corners, I'm often surprised about the incredible wonders right here on my doorstep in Wales.
Just look at the immense scale of that.
In this series, I'll be travelling the length and breadth of this country to discover some of these hidden secrets. Lost worlds beneath our feet. Industries that once powered the nation. And structures that will take your breath away. It's going to be exhilarating.
There we go! Woohoo!
And dangerous.
This is as tight as it gets now.
I thought I knew this country, but I was wrong. This is Wales as you've never seen it before. For such a small country, Wales has had more than its fair share of cutting-edge engineering. From pioneering nuclear power to world-leading aerospace manufacture, this country has continually punched above its weight. This began with the Industrial Revolution, which brought about an explosion of construction. From the little-known to the iconic. The Menai Bridge in North Wales was completed in 1826 and was world-leading in its design and structure. This bridge, constructed 200 years ago, provided not only the first mainland link into Anglesey, but it also created an unbroken road from London to Holyhead. It was the first suspension bridge of its kind in the world. It was designed by Thomas Telford, one of the most important architects of the Industrial Revolution. From the late 1700s, his pioneering designs of roads, canals and bridges transformed Britain by connecting its trade routes with incredible feats of engineering. But for me, his most outstanding achievements are here in Wales. As well as the graceful Menai Bridge and the regal Conwy Bridge, his crowning masterpiece sits a few miles south of Wrexham. In the late 18th century, the Industrial Revolution sparked a canal building mania to transport trade items all around Britain. The Llangollen Canal was a key part of that network, but this huge River Dee valley posed a big problem for the canal builders. Thomas Telford came up with a stunning solution: the largest aqueduct in Britain.
Really weird looking up there, Linda. It's almost like people are floating in the sky above our heads.
Well, it's known as the stream in the sky.
Is it?
So it's a local nickname.
Is that right? How did they go about building this?
Well, they had different ideas of how they were going to do it. It might have been a series of locks at one point, and then they just went, no, let's go straight across the valley. They've had to do a lot of construction work with embankments on either side to help it to even it out. But yeah, it's amazing, isn't it, all the way straight across. They used all sorts of different products to actually build it. Yes, you've got sandstone, but within the mortar, they've actually used ox blood.
Ox blood?
They do, yeah.
You're joking.
No, they actually believe it strengthened the mortar. And I like to say, well, it did the job.
That's pretty grim. I hope the vegetarians and vegans that walk along the aqueduct don't find out about that. How many pillars are there? 18
pillars and 19 arches.
18 pillars and 19 arches.
And they're as straight as a die from when you look from one side to the other, they're straight as anything.
It took 10 years to finish the Pontcysyllte aqueduct. When it opened in 1805, it was the missing piece that linked the canal network with the lucrative ironworks and collieries around Wrexham.
This was all before railways, so it was canals that we used to transport coal, iron, and all of our trade goods.
This bridge was considered one of Britain's finest feats of civil engineering, and it drew tourists from all over the country to wonder at it.
A piece of engineering genius. The highest navigable aqueduct in the world, and I'm about to kayak over it.
It's a 126-foot drop to the bottom of the river. And unbelievably, there's just a foot of the cast iron trough above the water to stop me falling over the edge.
Just coming into the middle of the aqueduct now. I thought I'd have a little look over this edge. Here we go. Let's check out the drop. Whoa. It's a long way down to the River Dee.
OK, so it's not exactly hidden, but the Pontcysyllta aqueduct is one of Wales's most impressive feats of engineering. But there is an even bigger one that would be just as iconic if you could see it. It's still in essential use today, but it's concealed deep underground. It's in mid-Wales, home to some of the most beautiful scenery of anywhere in the world.
I'm just coming into the top of Cwm Elan, the Elan Valley, this string of absolutely stunning reservoirs.
At the end of the 1800s, this epic landscape was significantly changed.
In the 19th century, Birmingham was riddled with contagious diseases caused by contaminated water. The council leader, Joseph Chamberlain, came up with the extraordinarily ambitious idea to take billions of gallons of fresh water from Wales to the city via a 118-kilometre tunnel.
Work began in 1893, with whole communities uprooted to make way for 4 giant lakes and 6 dams. Each day, this system delivers 16 million litres of water to Birmingham, via the tunnel at the bottom of this tower. It's a 3-day-long journey, the water travelling the 118 kilometres by gravity alone.
It's a unique system that still works today. But after 120 years, sections of that Victorian tunnel are starting to crumble.
The damaged tunnel section is 30 miles away in Knighton. The water company's solution is to construct a new replacement tunnel part and then connect it to the original Victorian aqueduct.
So we've got the old Victorian well house on the far side and the new structure which is nearing completion on this side.
Wow.
Ken McGregor is the project director in charge.
So where exactly does the pipe run?
The existing one runs round the side of this hill here, and then ours comes into the new well.
Right, and it runs all the way over there to the other well?
Yeah, so if you just see there's the siphon pipes come out of the well here and then swoop down the valley up to the other well at the far side.
From up here, there's a great view of the giant concrete vessel that marks the end of the new tunnel section.
It looks quite small from up here, but when we're down there, you'll see the full size of it, obviously.
The water will collect here before being forced down 4 giant pipes into a large U-bend section. This gets the water across the valley, where it then reconnects with the aqueduct on the other side.
Look at that tunnel!
The biggest challenge was carving out a 2-kilometre-long tunnel, 30 metres under the ground. This was done by a giant tunnel boring machine.
So this is classed as a segmental tunnel. You can see the rings. The rings are basically what makes the tunnel, and the rings are made up of segments, hence the name segmental. But no manual handling, so each segment is picked up at the back of the TBM with a hydraulic erector, and that's basically spun round with a guy on a remote control and placed in position, and then it's bolted to the next segment, and off we go.
At the end of this tunnel, a deep shaft has been dug out so the huge drill could start its job. Now that's finished, final work is being completed. Then the water supply can be diverted from the old pipe section to the new.
Goodness me, if we just stop here a second and listen to that.
Yeah, so what we're doing at the end of the tunnel here, we're still breaking out the bottom of the shaft. So that's a big breaker working away, breaking out the hard rock in the bottom. So we've got to dig out the rock and then form a concrete base to the bottom of the shaft. So that's what they're doing. Obviously you can hear the echo coming all the way up the tunnel, and it sounds a lot closer than it is, but probably from here it's probably about 1.5 kilometres away.
The shaft is on the other side of Knighton. It took 2 years just to clear the hillside to start the work, but now it's near completion.
I'm above ground right at the end of the construction project, and that almighty racket that you can hear coming from that hole is actually what I could hear under the ground. This is the last piece of the jigsaw for this construction project.
By the time you watch this, the tunnel will be in use, sending water to Birmingham on its 3-day-long journey.
Just look over there. You can still see the very top of the viaduct that carried that tunnel on its way. For me though, what's most poignant about this place is that that new modern channel runs right alongside the Victorian one.
But not only that, apart from these new sections, the majority of the water's journey from mid-Wales to the Midlands is still via the original Victorian aqueduct. This exploration into engineering has shown me that Wales has always been home to some of the most forward-thinking and pioneering engineering projects in Europe. One of those lies on the most northerly part of the country, on the island of Anglesey. The Wilver nuclear power station opened in 1971. Back then it was the most powerful nuclear plant on the planet. Although Wilver has stopped operating and is now in the long process of decommissioning, I'm told inside it's an engineering phenomenon. What's amazing about Wilver is that it was going right up until 2015, so the complex machinery, the mega engineering, it's all still in there. But there is a significant flip side to that. Some of the nuclear rods are still in the nuclear core, which means I'm going to be getting about as close as possible to one of the most dangerous substances used to generate electricity. There it is. It's like a monolith. As nuclear fuel rods are still on site, there are extremely high security measures, but we've managed to secure exclusive access. Our escort is Medwin Williams, who's been working here for over 40 years. So the power station became operational in 1971?
That's correct, yes.
How long did it take to actually build?
It took 8 years to build. Construction first started back in 1963, so when you consider what they achieved in that 8 years' time, from cutting the first turf to actually commissioning the first turbine, it was quite an achievement.
It's absolutely enormous as well. I mean, what sort of scale are we looking at?
The output from the site is 1,000 megawatts of electricity, which is sufficient power to supply about 40% of Wales's needs.
40%?
That's correct.
Wilver is located on the coast because seawater was needed as a coolant to turn steam back into water after it had been used in the turbines. Millions of gallons were sucked into the station by these massive pumps.
the main cooling water comes in directly below us here on these large diameter pipes.
The really big ones just
The
there.
really big ones just there, yes.
Right.
So they will take the heat out of the steam, and effectively the seawater will discharge back out to sea about 6 degrees warmer than when it came in. At the far end, we have the high pressure steam turbine. So that's where the steam comes across over the overhead, these massive overhead pipes that we have, into the 3 low pressure cylinders that we have in front of us here.
High pressure steam drove the turbines, which then turned the generators to produce electricity. High pressure steam, huge temperatures. When this place was working with these turbines that are some of the biggest turbines man has ever built, it must have been like Dante's Inferno in here with the noise and the heat.
Absolutely, you could smell the oils, you could feel the heat. Yeah, it was an absolutely awesome place to work. We have a 175-ton crane at each end of the turbine hall. So that just gives you a feel for the size of the components that we're dealing with here, that these cranes have had to handle for the maintenance of these machines.
Everything about this place is supersized. The turbine hall is 250 metres long, and there are enough buildings on this 300-acre site to make up a small town. But the most important one is the building that creates the heat to generate the steam. The reactor building.
We're about to enter a radiation-controlled area, so we'll pick up an electronic personal dose meter. Pop that in a little pouch.
And that reads exactly 0 now.
And that's exactly what I expect it to read when we come back. Let's go up there.
This is it. There are 2 reactors here at Wilver, and Med takes me past one of them, showing me how a network of cables keeps the 12-foot thick concrete casing intact and the highly radioactive core safe.
These are the tendons that pre-stress the concrete itself.
So basically these here are straining it and compressing it and keeping everything together.
So that the concrete becomes the pressure vessel for the reactor.
Because if there wasn't any tension, then
The concrete would crumble.
On the next level of the reactor building is the charge face. This is where the uranium fuel rods used to be inserted into the core to make the nuclear chain reaction happen. Look at that! God, that's a weird feeling. There's people actually working down there as well. We're stood on top of a nuclear reactor.
Yeah.
God, it's a trippy feeling. Reactor 2 has already been decommissioned. This is Reactor 1, and there are still hundreds of radioactive fuel elements inside. I am now climbing up the side on top of a nuclear reactor. The core is underneath me. Wow.
Machinery's moving as well.
Goodness me.
You're in for a treat, Will.
There it is.
Those are the hydraulic power packs kicking in for the transport of the yellow bits to pick up the fueling machine.
And it's going to move across and go and get more
Very
rods.
shortly, it'll move across back towards Reactor 1 to pick up some more fuel.
It was this machine's job to replace spent uranium fuel elements with new ones via the holes in the charge face that lead straight into the reactor.
Okay, we'll fill it again.
Here we go, it's going. The machine's on the move. 600,000 were used over the course of this station's operational life. And now the machine is removing the last few hundred. It's a slow process. It's nerve jangling working at any height, but when you're at height above a live nuclear reactor core, there are moments where you feel a little bit mad. Look at that! Once the fuel elements have been removed, they're sealed inside a huge concrete container and sent down to Sellafield for reprocessing.
This machine now has just finished discharging the fuel at the primary dry store cell for disposal. It's now just come back to the reactor, and it'll pick up another 16 elements, and it'll repeat that process until we eventually defuel the whole of Reactor 1. And the team just beyond the fueling machine there, they're carrying on with the fuel-free verification, proving...
Oh, I can actually see his screen now.
Yeah.
That
black hole I can see on that screen.
He's actually looking down a hole there.
That's
now.
going down into the core, isn't it?
Actually, yeah.
Wow.
Since filming, the very last container has been taken away, and the long job of deconstructing the remaining machinery has begun. There were plans to build a new nuclear station on this site at the cost of £16 billion, but they've now been shelved.
What's the future look like for nuclear in Wales?
I honestly don't know the answer to that. It's very much in the hands of the private investors and the government of this country. I would like to think that we'll end up with a correct energy mix, including renewables, tidal energy and so forth, and not be too reliant on supplies from other countries to meet our needs, that we'll be self-sufficient as a country. And I firmly believe that nuclear is a part in that energy mix.
Nuclear power in Wales has now gone the same way as many of the industries with which this country once led the world. But one company is showing there's a new path to engineering success in Wales. I've come to Flintshire to see the very latest in high-tech engineering.
This is Airbus Broughton. Now, I've had to go through quite a lot of security to get to this point, but let's go and see what engineering in Wales looks like today.
Airbus is the largest airline manufacturer on the planet, and this huge facility is where they build the wings for their entire range of planes. One of those is among the biggest transport aircraft the world has ever seen, the Airbus Beluga. These giant freight planes have been built to transport the huge wings from this Welsh factory to the assembly lines in Europe.
Look at that. Just about see the pilot in the top up there. But the plane itself is just towering up ahead. It's over 50 metres long, the wingspan is almost 50 metres. It's more like a spaceship than an aeroplane when you're up close to it. Seriously, seriously impressive.
It's one of the most high-tech factories in the world, with much of the work done by robots. But human, Jack Skilling, is a wing engineer, and he's going to show me around.
You can really see the extent of this factory. There's actually up to 30 wings under construction at any one time in the complex.
So this is where the covers are going to be drilled and bolted to the spars, and the spars and the ribs are actually going to be bolted together as well.
Right, OK. Here it comes now.
When this wing is finished, it weighs 21 tons and spans a massive 60 metres, almost the width of a rugby pitch. Incredibly, this hollow wing also holds the plane's fuel.
So this machine does the same kind of repetitive job every day, if you like.
At the next stage of the assembly line, a robot drills holes into the wing so the electronic components can be added.
What it does is every 100 holes, it kind of does a sanity check on, it measures a specific hole, kind of sees what it's done right, what it's done wrong, and reprograms itself to do the next 100 holes a bit better. So it's kind of continually learning and continually getting better.
Man, it's just like AI then, isn't it?
Yeah, definitely.
It's really interesting to see that around all of this machinery and robotics, there's still jobs that are being done by hand.
These bolts are actually fastened from the inside of the wing because the bottom and upper cover are kind of attached at this point. We can't get a robot inside the wing, so it's too finicky, basically, for a robot to do, so we have to get humans to do it.
We're going up, the head is opening of this plane.
I'm called back to the hangar as the Beluga that just landed is now ready to unload its cargo.
Wow, look at that! That is an unbelievable cargo hold.
Within just an hour, the crew have unloaded the delivery, and are beginning to load on its replacement, a wing for an Airbus A350 passenger plane. But inside the cargo bay, the size is completely mind-blowing.
Look at this. This is the loading bay. This is where that wing has just come out of. And obviously it's absolutely enormous, but what blows my mind is the carrying capacity of the Beluga plane that's bigger than this is 30% more. I was just chatting to a couple of the engineers and they were saying you almost couldn't go bigger because the tail of the plane has to have air going over it. It'd be almost like having another set of wings out the back there. You look down the edge here, the wings of this are pretty enormous as it is, but the tail is huge as well. Everything here is just on a super size. I mean, it's like walking down the rib cage of a whale.
But it's actually much bigger than a whale, a staggering 56 metres long, enough room to fit 2 adult blue whales nose to tail. Even the wingspan stretches an incredible 50 metres. Anything less, and this plane couldn't get off the ground.
All right, I've got to get out of here now because the wing is loaded and ready to come in here, and I'm holding up the process. This wing is over 20 tonnes in weight. It's one of the heaviest wings that they actually fly out of this facility. But the Beluga XL, the larger version of this plane, can actually take 2 of these wings. The Beluga XL is as big as they can go.
Just at that moment, a bit of luck. A brand new Beluga XL is coming into land.
And touchdown. What an extraordinary aircraft. When it is fully operational, it's expected to fly 6.5 million kilometres per year. That is the equivalent of 17 journeys to the moon. That is Airbus's workhorse.
And it's big money. The planes this Beluga XL carries parts for cost hundreds of millions of pounds each.
You don't need to go to the launch base of some space rocket to see the cutting edge in aerospace engineering. It's right here in Flintshire, North Wales.
As we've seen in this series, the big industries that once provided mass employment and created modern Wales have almost been reduced to nothing. But my time at Airbus showed me that Wales can be home to world-leading engineering technology, whilst providing thousands of jobs. Then the global pandemic happened.
What the next few months could hold for Wales as we continue to tackle coronavirus. Also in the programme, fears for jobs at the Airbus plant in Flintshire.
Since filming ended, the world has been devastated by coronavirus. Hundreds of thousands have lost their lives and the economy has been brought to a standstill. Airbus in North Wales has been hit hard.
More than 1,400 jobs will go at the Airbus factory in Flintshire. It's described as devastating for the entire economy of Wales.
There are tough times ahead, but places like this prove Wales has ingenuity and resourcefulness in abundance. I'm sure that will help us to find a way through.